So in this lesson today, we are going to find and interpret the expected values. This is big idea, use probability value at outcomes, and we're going to calculate the expected value of a random variable and interpret its means, interpret it as a means of giving probability distribution, basically to answer some questions. The expected value is a predicted value of a variable. In other words, it's the average result of an experiment after a large number of trials. It's the most likely value. It's the most likely value of a random variable outcome of an experiment, basically. Expected value can help size up whether a risk is worth the potential reward, and we're going to talk about that some. Okay, so the expected value is a weighted average of the possible outcomes of a random variable where the weights are the probabilities, okay, that the outcomes will occur. So weighted average is the average that multiplies each component by a factor representing its frequency or probability. So to determine the expected value of a variable, we're going to multiply each possible outcome by its probability of occurring. And then we're going to add all those together. So this is the formula that's on y'all's formula sheet. So what does this mean? This is expected value, okay, E of X. So this is the number of things, basically the sum of all the events starting with that are going to occur. How many times is something going to happen, right? And it starts, I always starts with 1. So basically what we're going to do is we're going to do the probability of X times the number of times that occurs. Okay, so that means, again, the first event, so this might be one thing, and then what's the probability of that one thing happen? And this is 2 things, and how many probability of that? 3 things, blah, 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 all the way up to the total. And we're going to talk about what that means in a minute. But that's the formula right there. That's the formula that's on the formula sheet. Most of y'all, it's not going to do you any good because you may or may not remember that this means the summation. That means we're going to add all these events together, adding, got it, of each event times this probability, each event times this probability, each event times this probability. That's what that is. All right, so when we look at our first example here, it says, below is a chart of the probability that a person works out 0 to 4 times a week from previously gathered data, okay? So X is the number of workouts a week. That's what this is talking about right here. X is the number of workouts a week, and these values are a finite set of numbers. So this is called a discrete random variable. Okay, that just means that there's not unlimited numbers of pieces of data there. There's 0 through 4 times. Okay, and then P of X is a probability that the workout occurred that number of times in the indicated in a week. So the probability in this column must add up to be 100. So if I were to add up all these numbers right here, these should add up to be 100. 1, actually, because you remember 1 is 100%, right? Okay, so then we're going to find the expected value using the data from the table. So what we're going to do on this one, we're going to take each X, and we're going to multiply it times the probability of X. That's what we're doing. And we're going to add all those, okay, as we go down the column. Okay, so we're going to do 0 times our 0.1 plus 1 times our 0.15 plus 2 times our 0.4. These are, again, remember the times they worked out in a week and the probability of that. And then 3 times 0.25 and then 4 times a week. The probability of that is 0.1. Okay, so we're going to add all those together, and we can put that right in our calculator and do that. And so when we do that, we get 2.1. Well, what does that mean? It says, what could this data be used for? Okay, so what does that really mean? Because obviously I'm not working out 2.1 times, but if I was working out 10 days, if I was going to say, or 10 weeks, if I wanted to know how many times on average would I work out in 10 weeks, couldn't I do the 2.1 times the 10? And that would mean in 10 weeks I would work out 21 times. What if I was talking about 100 weeks? Then the same thing, right? We could take that 100 weeks and we could do 2.1 times 100, and that would be 210 times in 100 weeks, okay? That's what that value actually means, okay? Now, and it's going to mean different things in different problems, okay? So we try one, says graduates from a large high school were asked the following. How many total AP courses did you take from 9th grade through 12th grade? The table below displays the distribution of the total number of AP courses taken by graduates while attending this high school. Compute the expected number of total AP courses taken per graduate. Now notice this is a different question, right? But the way we're going to do it's the same. So we're going to take our 0 times our 0.575 plus our 1 times our 0.06 plus 2 times 0.09 plus 3 times 0.12 plus 4 times 0.05. Great if I could actually write. Plus 6 times 0.035 plus 7 times 0.25 plus 8 times 0.005. Now you can put that directly in your calculator like that, okay? And when you do, you get 1.435. So it says compute the expected number of total AP courses taken per graduate. So it's 1.4. Not even 2, but 1.4. Okay? So now let's see if you guys can do the you try and come back to me when you're done. System says consider a game of chance with 4 prizes, $1, $2, $3, and $4, right? Where each outcome has a specific probability of happening as shown in the table below. What is the expected outcome? Notice if I was to add up these probabilities, I would get 100%, wouldn't I? Okay, so what we're going to do is we're going to do our 1 times our 0.5 plus our 2 times our 0.2. Remember, we're changing these to decimals, percents to decimals. And you could divide it by 100 to get that if you're not sure how to do that. 3 times 0.2 again, and 4 times our 0.1. So when I add all those up, I get 1.9. So basically, if I'm doing a game of chance with 4 prizes, and those are the probabilities of the prizes, then I'm expected to get $1.90 based on those probabilities of the outcome with those outcomes. Okay. The next one says at a carnival, there's a duck pond. There's a blue dot, purple dot, or red dot on the bottom of each duck. The prizes are blue 50 cent, purple $1.50, and red $5. The probabilities of winning are 60, 30, and 10. Okay? It says, what's the expected value of the game? So what we want to do is take our blue and multiply it times our blue percent. So we're going to do 0.5 times 0.6, because remember, 60% is 0.6. Then we got purple. Let's see if I can pull a purple up here, y'all. There's purple. So there's our purple and our purple. So this is going to be plus 1.5 times 0.3. And then we got our red, right? So that's going to be plus our red, which is 5 times 0.1. Okay, so when you do all that in your calculator again, I got 1.9. No, sorry. That's not right. I got 1.25. Okay? So it says, imagine that the charity is hosting the carnival to raise funds for the cause. So the cost to play the game is $2. What is the payoff expected net earnings? So if the expected outcome is $1.25, but they're paying $2, so aren't we going to take that $2 and subtract from it that $1.25? Yes, indeed. So the expected payoff for earnings per game is going to be 75 cents, isn't it, y'all? Indeed. Okay? All right, we try 2. Says you are in charge of the booth for a game at the fair. In the game, players pick a card at random from the deck. If the card is an ace, the player wins $20. What is the maximum amount you should charge to feel confident that you will make a profit? Or the minimum amount you should charge to feel confident you'll make a profit by the end of the fair. Okay, so when we look at a question like this, what we're going to do is we're going to, again, find the outcome, right? So what is the probability that a card's an ace in a deck? So there are 4 aces in the deck, so that's 4 over 52, right? And if we are going to pay $20, we want to multiply that times 20. So 4 over 52 times 20. And when we do that, that is $1.54. So I would say if you really want to make a profit that you need to actually charge at least $2, right? So then at least you're making 46 cents per person that plays. Okay? You might want to charge more, but I would say at least, $2. All right, you try 2 says, let's see if you guys can do this one. Come back to me when you're done. There's another game where players pick 2 cards without replacing the first pull. The player can win $50 if either of the situations occurs. A pair, actually just a pair. There's not supposed to be an or there, y'all. A pair. What's the probability that they pull a pair? Okay, so how many cards are in a pair? So if I pull the first card, so it's going to be in a suit, right? So that's 4 over 52, right? And then we're going to multiply that by the other card. So if I get the first card in a suit, that's 4 out of 52. And if I get the second card in a suit, that's going to be 3 out of 51, right? So that's going to be 12 over. So when I multiply the 52 times 51, I get 2652. And if I turn that into a percent, now you can just do that 12 divided by 2652, right? But if you turn that into an actual decimal, that's going to be 0.005 basically if you round it. But you can just take that 12 over 2652 and you can multiply it by that 50. And if you do that, you're going to get that it's 25 cents. So it says there's another game that players pick 2 cards without replacing the first card. The player wins $50 if either of the situations occurs. What's the expected value of this game? And this is just 25 cents, right? So, because again, you get $50 if you do it. So, you could almost spend 50 cents, right, on a ticket and it would be worth your while, right? Anything above 25 cents and it would be worth your while. All right, so example 3 says, a game at the Shelby County Fair costs $2 to play. In this game, you have to roll an 8-sided die and spin the wheel shown with 5 sections: orange, red, blue, green, purple. You can win $10 by doing any of the following. Okay, so what we're going to have to do here is we're going to have to find the percent of each of these and then multiply it times the 10 to find out what our expected value is going to be. Okay, so rolling a 2, 4, or 8. So rolling a 2, that's 1 out of 8, plus a 4, 1 out of 8, plus an 8 is 1 out of 8, sorry, those are supposed to be 1 out of 8. Wait, let me go back and do this again. Okay, rolling a 2, that's 1 out of 8. And remember, it says or, so we're going to add. That's a 4 is 1 out of 8, and an 8 is 1 out of 8. So this is going to be 3 eighths here. And then it says and. See that word and? So we're going to multiply that. And how many areas are there to spin in, right? It says spinning purple. So that's going to be 1 color out of 5, right? So when I do that, that's going to be 3 over 40, right? Now remember, we're going to take that percent, whatever that is, that decimal, and multiply it by 10. And when I did that, I got that this was 0.075 cents, right? Okay. Now remember, we're going to add all these together when we get done. Then we got rolling an odd number. How many odds are there? 1, 3, 5, 7, 9, right? 1, 3, 5, 7, 9. That's 5, right? No, there's not a 9. 1, 3, 5, 7. That's 4, right? Okay, so this is going to be 4 out of 8, right? And then spinning a green or red. Okay, so now we got 2 out of the 5, right? So that's, and it's going to be multiplying against this. It's going to be 2 out of the 5. So that's going to be 8 out of 40. And so we're going to multiply that times our 10. And when we do, we get that this one is $2. Okay. We got one more. Rolling a 1. Okay, that's going to be 1 out of 8. And again, multiplying, spinning blue. That's just going to be 1 out of 5, right? So that's going to be 1 over 40, again, times our 10. So when we do this one, we get 25 cents. So now remember, what we do to find our expected value is we're going to add those together. 0.075 plus 2 plus our 0.25, and that is $3, right? Okay, so obviously we want to charge more. It says at the fair you pay $2 to play, right? And so if you're only paying $2 to pay, then you're probably going to make $1 more every time if you play more than a few times, right? Okay. At a carnival, Jasmine is playing a game with the dartboard below. The dartboard has a rectangular shaped top and a semicircle along the bottom. She throws a dart and lands randomly at the dartboard and wins a number. Tickets shown in each region. Determine the expected value of the game. So what we got to do on this one is got to find the area, okay? So let's find the one ticket first, this one down here. So this is the circle, right? So we're going to do one ticket. So this is going to be equal to pi times our radius, and our radius is from there to there, right? And that's 2 feet, right? So this is going to be 2 squared. And then aren't we going to divide that by 2 because it's only half a circle, right? So that's going to be pi, 2 pi, right? So then that's going to be 6.28. It is, okay? Feet squared, okay? Then we're going to talk about, let me see if I can get my colors right, the ones that are here. So let's see if we can find the orange next, okay? So that's going to be our 2 tickets. So the ones that are 2 tickets. Okay, so what I can do is, again, I could do 2 times, because I've got 2 triangles, of 1/2 base, which is 2 feet wide, so your base right here. 1/2 of 2 times our height, which is right here, times 3, right? Well, half of 2 is 1, so that's just going to be 2 times 3, isn't it? So this is going to be 6 feet squared. And then we got our purple section, okay, ish, and that's 3 tickets, right? So here's our 3 tickets, and that's going to be equal to, our triangle is 1/2, our base is up here, that's 4, right? 4 times our height, which is 3, right? 4 times 3, so that's half of 12, so that's also 6 feet squared. So to find the probability of each of these areas, we need to find out what the total is, and we need to find out what percent of the whole each of these is, okay? So I'm going to add up these 3 numbers. When I add them up, I'm going to get 6, 6, 6, 18, so that's going to be 18.28, right? So we're going to divide every one of these by 18.28 so that we can figure out what percent of the whole each of them is, okay? And this is a little trickier problem, okay? So when we divide 6.28 by 18.28, I got 0.34. When I do this one, I got 0.33. And then when I got this one, I also got 0.33. Right now, what we have to do to find the weighted average is we got to multiply those numbers by our tickets, okay? So for the first one, we have 1 ticket, right? So that's just going to be 0.34. For our second one, which was our orangish color, right? So this is going to be multiplied by 2. And so that's going to be 0.66, right? And for our third one, which was our purple one, this one's going to be times 3. So that's going to be 0.99. Now what we're going to do is add these 3 together, right? That's going to give our total for what this is worth. And so it's $1. I got $1.99 when I added them together, okay? $1.99, okay? That's what it is. That's the expected value of the game. All right, let's see if you guys can do you try 3. Come back to me when you're done. All right, this one says, suppose an individual thinks that if they quit their job and work for themselves, that there is a 60% chance they could earn $20,000. So that would be 0.6 times 20,000 plus in their first year, and a 30% chance they could earn 60,000. So that would be 0.3 times 60,000. And a 10% chance that they would earn nothing. Okay, so that would be plus our 0.1 times 0. Okay, so when we do all 3 of these and we add them together, that equals $30,000. So the real question is, what do you make it now? right? So if you're making less than $30,000 a year, then yes, it might be worth the risk, right? But if you're making more than $30,000, then you better weigh the risk. Okay, that's the deal. All right, so what is the expected value and what is the payoff? That's what this one says. Okay, let me grab this because it's kind of up there. All right, so Manny is arguing with his mother about whether he should pay $75, buy a $75 light for his motorcycle. His mother wants him to be safe, but Manny thinks the light's too expensive. Based on the traffic data, Manny makes a table below that shows the time, probability, and cost of 3 different types of accidents if Manny doesn't have the light. Should Manny buy the light? Okay, so first thing I want you to notice, when you add these up, they don't add up to 100%. Why? Because there's a 0 probability of him basically getting in an accident during the day due to not having a light, okay? So that's why if you add these up, you get 50%, right? Because 50% of the time, it's not morning, dusk, or night. Got it? All right, so now what we're going to do to get the value here is we're going to multiply the 5,000 times the 0.5, right? Or 0.05, sorry. Remember, that's 0.05, okay? And then we're going to add the 3,000 times the 0.2 plus the 8,000 times the 0.25. Now, it doesn't matter whether you do the percent first or the number first. It really doesn't matter. But you got to do both of these, okay? So when we do this, I add them all together. I get 2,850, okay? So if the opportunity cost, that's what this would be, is $2,850, but it only costs $75 for the light, what would you say? Me too. I would say yes. We got to buy the light because, you know, that's the risk that you're putting out there, y'all, for a $75 light, okay? All right, the next one says, suppose you're planning to buy a computer. The computer comes with a 1-year warranty, but you can purchase a warranty for an additional year for $24.95. Your research indicates that the second year, there's a 1 in 20 chance of incurring a major repair that costs $180, right? And a probability of 0.15 of a minor repair that costs $65. Is it worth purchasing the additional warranty? Why not? So when I do this, and I can do this in the calculator just exactly like this, right? So this would have been 9 plus $9.75. So that's equal to $18.75, okay? So the question here again is, you got $18.75, that's your risk, $18.75 versus the $24.95. So this is how you weigh the question, right? So am I willing to spend $24.95 for $18.75 of risk? Because that's what this is talking about. For a lot of people, they would say no, because this is too much. The difference is what? About, what is that, $6? A little more than $6, actually. Y'all got me? So that's the difference because it's a $6 difference. What's actually, what is that? $24.95 minus the 18.75. So it's basically, whoa, I didn't do that right. $24.95 minus 18.75. So it's a $6.27 difference. So again, are you willing to spend $6.20 more than your risk? That's up to you. All right, do the you try for, come back to me when you're done. So this one says you're in charge of a booth for a game at the fair. In the game, players pick a card at random from a standard deck. If the card is a jack, queen, or king, so there are 12 jack, king, queens, or kings in a deck out of the 52, the player wins $5. If the player have to pay $1 to play, is it worth playing the game? So we're going to multiply this times the 5, okay? So 12 over 52 times the 5 is $1.15. So if you only had to pay $1, is it worth it? I would say yes. Why? Because you are going to get 15 cents more. Y'all see it? Okay. All right, so the next couple are practice, so you guys can do these and come back to me when you're done. A dart's thrown and lands at a random spot on each target. If a person hits one of the circles, they receive $3. If they hit the region outside the circle, they have to pay $5. What is the expected value of the game? Write your answer as a percent rounded to the nearest tenth. Okay, so when we do this, this says that this is 3, so that means my radius right here would be 1.5, right? So to find that area, that's going to be 1.5 squared times pi, right? Pi r squared. So 1.5 squared, I got this on here somewhere. So one circle would be equal to 1.5 squared pi times pi, right? So that's going to be 2.25 pi. And there's 2 of those, right? So let's just multiply that by 2. So that's going to give us 4.5 pi. And then we multiply that by pi, that's going to be 14.14, yes? Okay? So that's for the circles, okay? And then what is the area of the whole space? That's going to be 3. So the rectangle is going to be 3 times 6. That's 18, right? Now let's find the area outside that, okay? So that's our rectangle. So then we're going to do 18 minus the 14.14. That's going to give us our area outside the rectangle. And when I did that, that's going to be 3.86. Then we're going to have to divide these by our 18, right? And by our 18 to see what the probability is, right? So this was 0.786. This was equal to 0.214 or 0.79 and 0.21. And then, of course, we're going to have to multiply those by our price. Okay, so this one's 3 and this one's minus 5. Okay, so that means, hold on, let me move this over. So when I did the top number and I multiplied that, I got that this was $2.37. And then when I did the bottom number, times the minus 5, that's minus 1.05. So it says, what is the expected value of the game? And because we're giving money back, that's why it's the minus 5. Y'all got that? They pay $5. That's why it's that. So when we do this, this is $1.32. That's the expected value of the game, okay? The next one says you are a contestant on a game show. The first round, the host gives you $200. You can choose to keep the money or give the money back and spin the wheel, determining your winnings. All the sections on the wheel are equal in size. What is the expected value of the game? Is it worth playing or keep the $200? Okay, so we're going to have to find every one of these, right? So there's 8 sections. They're equal areas, right? So what we're going to do is I got a 100 here, a 100 here, and a 100 there, right? So I'm going to do the 100. So that's going to be 1/8 times, so that's the probability is 1/8, right? Times my 100. So when I do that, I get $12.50, and there were 3 of those, right? So that's going to be, what is that? 37.50. Okay. Then I've got 200. So I'm going to do 2. Actually, let's just do 1/8 again. So if we do 1/8 times our 200, then that's going to be 25. And we got 2 of those, right? So that's going to be 50. Okay, let's keep going. And then we got 300, right? So that's going to be 1/8 times 300. It's going to be 300 divided by 8, which was 37.50. Okay, let's find another color here. So then we got our 400, right? I got only the 400 left, right? So we're going to do 1/8 times 400. And when I did that, I got 50. Okay? Now, what are we going to do? We're going to add all those together, right? And we're going to see what our expected value is. So we're going to add the 3750 to the 50 to the 3750. Did I get 3750 twice? Oh, wait a minute. 400 was 50. Did I have a 500? Ooh, I did. I missed one. There's a 500 as well. Ah, right there. 500. Y'all see it? I only had 3, 4, 5, 6, 7. So I had one more. I almost missed it. So we got our 1/8 times the 500. And that would have been 6250, right? So these are the numbers we're going to add together, guys. Okay, I'm going to actually do it in yellow so y'all can see it. We're going to add the 3750, the 50, the 3750 here, the 50, and the 6250. Okay, that's what we're doing. We're adding all those numbers together. And when I did that, I got $237.50. Okay, so it says the host gives you $200. So if the host gives you $200 and you subtract that from it, what do you now have? $37.50. So again, risk reward, right? Are you willing to risk the $200 to potentially get $37.50 more? Some people would say yes. Some people would say no. Okay. Most people would say yes because you're going to get more for the most part. Okay. All right. The next one says, in a game when you roll 6-sided dice, you win $5 if you roll a 3. If you don't roll a 3, then you have to pay $1. Okay. So this one is 1 out of 6, you get $5, right? And then if you don't roll the 3, it's going to be 5 out of 6, right? And that's going to be times paying $1, right, y'all? So that's where you're going to do this one. Remember, if you're paying out, then it's going to be a negative amount, yes? So this is actually 0.83 minus 0.83, so it's 0. So I would say it's up to you if it's 0, but most people, the expected value is 0, so I would say no, I'm not playing this game. All right, the other one is you can roll the 6-sided dice twice. You can win $8 if you roll an even number, so the probability of rolling an even number is 3/6, right? Or if you roll an even number and that's a multiplication, right? 3 or 5. So this is going to be 1/6 plus 1/6. So this is going to be 3/6 times 2/6, right? So that's going to be, 6/36, right? Okay. And it says it's $8 for you to do this. So $8, that's $1.33. So you can win $8, but it doesn't say how much you paid. So the real question is, if you paid anything less than $1.33, then I would say yep. So if you paid less than $1.33 for the ticket, then the answer is yes, I'm on. Got it? Okay.